Welcome back everyone, this is Ryan here, and in this video we are going to be finishing off our model for the calculator. So what we're going to do is we're going to need to create a class called calculation, which we'll get to in a minute, but before we can get started on that, what we're going to do is download a third-party library, which is called Arity, and unfortunately I don't think this project is well maintained, or maintained at all at this point, but it will serve the purposes of our project. And what you can do is I'll just put the link to this download page down in the description box. And what you're going to do is you're just going to go down to this section that says try it down here. Go ahead and download the jar. With that jar, what you'll do is you'll open up your project folder and go ahead and navigate to the app folder and then libs. And you're going to place the library right in the libs folder. And then what we'll do is we'll hop into Android Studio and Gradle, and we'll see how to sort of add it through Gradle, add a jar through Gradle. Okay, so I added the Arity jar to my libs folder, and if you're having any issues with that, you may need to do a Gradle sync, and that might, or do clean the project. Just go to build and then clean project. And what you should be able to do is just open up this app and then libs folder, and you should see the jar sitting right there. So if that's not, then chances are you might have put it in the wrong folder or something like that. So anyways, how do we get this working with Gradle? All that we do is just add this one line here, and this is assuming that you've already got this stuff generated, which is a compile file tree blah 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 command. And so all I've done is just add a line here, libs/arity-2.1.2.jar, and that's between apostrophes. And all we should need to do is a quick Gradle sync, and that should be set up properly for us. Waiting. Perfect. So Arity should be set up and ready to go for us. So what we'll do next is we'll just create a new Java class. Go ahead and go to source, main, Java, and our main package here, and we're going to create a new class called calculation, and that's just a plain old Java class. Calculation. Alright, and let me just find my notes here. So this is going to be kind of an interesting class. So it's going to serve two purposes. The first purpose is that it's going to maintain our current expression variable, which represents whatever's sort of in the display of the calculator. So that's its first job. Its second job is it's actually going to receive input from the calculator presenter, and it's going to kind of decide if that input is valid. If it's valid, then it's going to return the updated current expression to our presenter, and then our presenter is going to forward that to our display fragment, which will then draw it on the screen. In the event that it's not a valid change to or addition or anything like that to current expression, then what's going to happen is it's going to relay an error message instead. Then again, the presenter is going to relay that error message to the fragment, and the fragment will, instead of putting that in the display, it's going to just have a toast message pop up. So if I kind of lost you a little bit there, that's okay. We should sort of see it in action while we're coding. But yeah, let's just kind of jump into this. So we're going to kind of do this in two steps. Let's just set up sort of the basics of this class, and then we'll get into something kind of interesting, which is sort of how to tackle complicated and annoying large numbers of methods, and I'll show you a practical approach for dealing with that kind of thing. But for starters, we're going to create a couple different things here. So first is we're going to create a symbols variable, and this is what comes from the Arity library. Now, unfortunately, the documentation for Arity, if you had a look at it, is very poor. So I'm not really going to be able to explain to you how this works very well. You're just going to have to kind of bear with me, and that's not really my fault because their documentation is kind of non-existent. But to be fair, it's a third-party thing that apparently no one is maintaining, and it, as we'll see, it actually works quite well. So not to diss them or anything, but you'll just have to bear with me. So this symbols object is what we're going to use to actually perform our calculations. We're going to make a variable called calculation result, which is actually an interface, calculation result. Let's see here. And we haven't made that yet, so that's going to show up as red. And that is the way that we're going to communicate with our presenter. So that's going to be red for a while. That's totally fine. What we're going to do is, let's see here. So let's go ahead and create that interface first and foremost so we can clean this up. So we're going to say interface, calculation result, of course, calculation result, and just curly brackets, and we're just going to have one method here, void on expression changed. So that's anytime the expression, actually let me create that now. Let's just say private, and I believe that was a string here. Private static string current expression. And of course this is what's, as I said, going to represent our display. And so what's going to happen is we're going to have string result here and Boolean successful, and I'll explain what this stuff is here. So what's going to happen is anytime we try and make any change to our current expression, as I explained earlier, then we're going to fire this method. If this Boolean returns true, then we are going to return the updated current expression. Otherwise, if it's false, we're going to return just an error message, whatever we kind of want to add in there. So that's basically what's going on with this interface. And so yeah. And it's complaining about this because it hasn't been initialized, but we'll deal with that in a moment. Let's go ahead and create our constructor just to get that red out of there. So we're going to say public void calculation. And it's just going to create a new symbols object. Oops, I really can't type tonight. Symbols equals new symbols, and we don't need to pass anything to that, and that should get set up. Why is it complaining? Sorry, just give me a moment here. Well, I'm really on a roll tonight, so the reason why that's screwing up is because constructors don't actually return void, something I probably should have known after getting on to 3 years of Java programming. So that should clean that up. And let's see here, is there anything else? Let's just create a method to set our interface. I do apologize if this stuff is kind of just boring and I'm not doing a whole lot of exposition here, but this really is the boring part of programming where, sorry, just give me 1 second, calculation result listener. There's not a whole lot of explaining for me to do. We're kind of just typing in the code and just getting everything to work at this point. So I do apologize if it's a bit boring, but this is really, as I say, this is what programming is about. This is what you're getting into. Calculation result. And then we just say, let's see here, this dot calculation result equals calculation result. And in this method, we're also going to initialize current expression just to a blank, or an empty string, I should say. And that's probably optional. What's going on here? Why are you complaining? Current expression. All right. As you can probably tell at this point, it's quite late at night, and I'm having to do this after work, so that's what all the mistakes are about, just pure incompetence, so I do apologize about that. All right, so what we'll do is we've got the basics of this class set up, and now we just need to basically set up all the methods that are going to be called on it to manipulate the current expression object. And the way that we're going to do that is something that I learned from this really awesome online course, which was called Systematic Program Design. It's a free course on edX, and I'm not paid to say this, but I really enjoyed the course, and it had a lot of really awesome fundamentals in it about writing good code. So what I'm going to do is kind of take a lesson from it and show you how to sort of a method which you can apply to sort out some relatively complex methods. And so yeah, we'll just jump into that now. Okay, so what we're going to do now is I'm going to show you how to set up your IDE, assuming you're using Android Studio, to sort of help this process, and also we'll get started typing out method stubs and type comments and things like that, and I'll explain what those are as I kind of start working on them. So first things first, we need a little bit more room here, so make sure you open up Calculator Contract, just have it up in a tab here, and I'm going to click on the Project tab right here to just get some more room. And what we'll do is right-click on this calculator contract.java and hit split vertically. And what that's going to do is it's going to allow us to have these two windows side by side, and that way we can kind of see directly what we need to be working on. And because all of the methods inside of calculation are going to correspond to these methods here, this is going to be our guide for how we build this class. Now, it's going to be our guide for the basics, but I'm going to show you a method that you can use when you need to figure out a large number of slightly complicated methods. And so yeah, we'll just kind of jump into doing that. So obviously, each of these methods here is going to need a corresponding method in the calculation class. Now we're not going to name them the same thing because we're going to name them things appropriate to this calculation class. What we can do is get started with some type comments and some method stubs, and that's going to do a couple things. It's going to sort of keep a list of things that we need to handle. It's going to, when we actually start typing out the comments, you'll see how the way in which we do it actually helps us write the actual methods themselves. And yeah, well, that's pretty much it. So what we'll do is let's start with just one single method stub here. Type public void, and we're going to say delete character. And that is, of course, going to be the method for onDelete shortclick. And what we're going to do is we have 6 of these methods that we need to figure out. Show result and show toast message are handled with our interface method, and we'll see how that works later on. But what we're going to do is let's just copy this, and we're going to make 6 method stubs total. 1, 2, 3, 4, 5, 6. And we'll give them some better names. So this is going to be delete expression. So that's obviously when someone does a long click, we want to delete the whole expression. I'll just rename them, then we'll talk about them after that. We'll do append number, append operator, append decimal, and what was the last one here? I already forgot. Perform evaluation. There we go. Perform evaluation. And that's when someone hits the equals button. So let's just start with delete character. Now this is a pretty simple one, but let's just let's write out a quick comment to help us out. Now the way that you set up Java doc comments is, and those are kind of a handy thing, if you want to generate Java docs for your projects, then you can just do it like this. But also this is just a handy way of creating nice typed comments. Type slash or backslash, I can't remember which one, and then 2 asterisks, and then just hit enter, and that'll create a little comment block there which you can use. And so let's just talk about what delete character is going to do. Basically, let's just, let me find my notes here. So what delete character is going to do is delete a single character from current expression. And again, current expression is sort of the string which represents our current expression or the expression after it's been evaluated, blah, blah, blah. Hopefully you get that. And now, let's kind of just think about this. What's a scenario where we wouldn't want to actually delete a character from our expression? And there's really one main scenario I could think of, and that's unless it's empty. So just type delete a single character from current expression unless empty. Now, I've obviously figured all this stuff out ahead of time, so it's going to be a lot more natural. But what we can do is, just to kind of help us out, we can figure out some and type out some scenarios which will sort of give us some hints as to what might be a valid and invalid kind of input. So for example, if the current expression is blank, that's going to be invalid. If it's 543, that's fine. If it has an operator in it already, that's totally fine as well. So those are scenarios that are valid. Now, when I'm going through and doing all of these, you'll probably catch me making some screw-ups or not handling certain scenarios. And the reason for that is that I really don't want to waste your time and spend like 50 minutes going through and making all of these methods absolutely airtight. That's not the point of this tutorial. What I'm trying to do right now is just show you a process that can sort of guide the creation of methods. And quite frankly, I'm not really concerned about people who are going to try really hard to break our program. In general, when you're creating apps for the public, you're going to want to handle as many of these scenarios as possible, and you're going to want to make it hard for the user to actually break the program. But in this particular case, I'm going to assume that the user is not going to set out to do that, but we are going to handle some very basic situations nonetheless. So that's basically it for delete character. Now the power of doing these comments is I've already sort of written the method in pseudocode. Delete a single character from a current expression unless it's empty. So that quite easily translates to if current expression dot length, it's a string, so we just call that dot length method, is greater than 0, then we can do what we want to do here. Else, we're just going to say calculation result, this is our interface, on expression changed, invalid input, so that'll be the message that we send to display fragment, which will then turn it into a toast. And we're going to return false. And we'll kind of see how false works when we get to the presenter. Basically, by specifying true or false, our presenter is going to know whether to call the, which method? It's going to know whether to call the show result method or the show toast message method, but we'll get to that later on. So that's all we need to do for the else case there. Now what happens when this thing is valid? Well, what we're going to do, and again, I've worked this stuff out ahead of time, so it's going to seem a lot more natural, but current expression equals current expression dot substring, and then we're going to type 0, which is the starting index, and current expression dot length -1. Don't ask why this is 0 and -1. For some reason, the substring method is really bizarre and it takes some getting used to, but yeah. So what this is going to do is it's just going to remove the character, whatever it is, from the end of current expression. It's just going to make a new substring, which just doesn't include that last character. And so that's the modification we want to make. Then we can just type calculation result dot on expression changed. And this time, we're going to actually pass current expression, and we're going to say true. And so now, obviously, calculator presenter, in this case, is going to know that we want to actually update the display with whatever change that we just made to current expression. That's it for delete character. Let's move on to delete expression. I'm going to be kind of lazy with this one. Basically, same thing. Delete entire expression unless empty. I'm just going to type empty string is invalid. That's basically what that means. And all we're going to do is just type current expression equals empty string. And we'll say if current expression dot equals, and then just empty string, curly brackets. So if it already equals an empty string, we're not even, well, I guess we can send an error message, but it's almost not even worth handling at that point. But yeah, let's just type that. So if current expression is already blank and we're trying to delete the whole expression, then there's no point. Otherwise, current expression equals empty string, and then calculation result dot on expression changed, and we can again pass current expression, which is just an empty string, and true. And like, why would I pass current expression instead of just two quotation marks, for example? Well, this wouldn't actually break our program, but it's just kind of an interesting little tangent here, is that this basically makes sure that by always passing current expression here, whenever we send something to display, it basically ensures that our display fragment and our current expression variable are always consistent. Now, I don't know if there will be any scenarios where it wouldn't be, but it's just kind of a good programming practice there. So let's get into our methods here. So these ones are a little more complicated. Let's talk about append number first. First, go ahead and create your type comment. Actually, sorry, don't do that, because we're going to make a little modification. So append number is actually going to receive a string number. And now you might be wondering, if you look over here, on number click, which is when this will be fired, actually passes an int. And the reason why it passes an int is because I wanted to handle converting the number to a string in calculator presenter, and that's just to keep the view as dumb as possible. That's something I probably could have done in the fragment itself, but it's sort of it's the same amount of code, and by doing it in the presenter, to me, it just makes a little bit more sense. It's a little more consistent with keeping the view stupid and the presenter smart. But yeah, that's all that's going on there. So yeah, append number. This one's a little more complicated. So now that we've added this parameter here, when we go to create our type comment, it actually adds it for us. And so yeah, what we're going to do is we're going to type out for append number to current expression if valid. And then below we'll just define what valid is. So 0. There's one scenario in particular where I don't want to append a number. So if the first character in current expression is 0, then and the number is 0, the number that we're trying to add to current expression, then I don't want that to be sort of legal. I don't want that to be valid. So we'll type current expression equals 0 and number is 0. That's going to be invalid. Also, if we have I'm going to impose a limit on the number of characters that you can kind of add to current expression. So we'll just type like, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That's going to be invalid. We're going to set a hard limit of 16 characters. Now, I'm not going to bother typing out like what is valid. We can kind of infer it from that. For number, that's quite self-explanatory, so I won't even bother writing out that type comment. We're just kind of being lazy and going through this quickly, as you can see. So yeah, so we've got some hints as to what we don't want to have happen. If current expression dot starts with 0 and number dot equals 0. So number is obviously whichever number button was pressed by the user. So if they hit 0 and current expression starts with 0, then I don't want to append a 0 onto that. That's not really going to make sense. So in that case, we're going to say calculation. Well, let's just copy and paste it. There's not really any point in typing it all out. In that case, we're going to send an error message. Else. So that's our first check. Does it start with 0 and does number equal 0? Now, the only other thing that I'm going to worry about at this point is the expression already quite long? Is it longer than I want it to be? If current expression dot length is greater than, less than or equal to 16. That's fine. In that case, we'll pass our update. Else, we're going to again just say invalid input, except we'll be a little bit more specific for this one. Expression too long. Perfect. All right, so we've only got a couple more. I know this might be a little boring, but I figured I'd go through all of it with you guys, because that might be easier than just copying and pasting it in. I don't know. If you don't want to bother typing out all of this stuff, then what you can do is just go ahead and check out the GitHub. I have a link in the description box, and you can just copy and paste this stuff in if it isn't that interesting. Here, again, we're going to say string operator. I know that it's going to be a string because it's passed in through this method here. And we'll just type that. Operator. Now, we're going to be a little more specific for this. And this is really up to personal preference, but I'm going to say operator is one of asterisk. And I'll just copy and paste these in. I'm just showing you guys just various examples of what you can do with these type comments. So this might not actually be useful to this particular situation, but I'm just trying to give some hints to that effect. And this is going to say append an operator to current expression if valid. And so what are we going to do to check if things are valid? So for starters, let's do a couple examples. 56, that's a totally valid scenario. 56 asterisk is not valid because I don't want to append an operator to an operator. So we're going to call that invalid. Let's see, 56 times 2, that's okay. I don't mind multiple operators as long as they're separated by numbers. So that's going to be valid. And then we'll just do one more. I don't want it to be blank. So that's going to be invalid. Now, here's the thing. By looking at this, there are a lot of scenarios where this would be an invalid. This would end up as invalid. And I don't particularly want to inflate several methods with all of this code. So what I'm going to do is I'm actually going to create what's called a helper function or helper method to actually do these checks for us. So what we'll do is just go down there, and we're going to call this method public Boolean. It's going to return a Boolean or Boolean, however you pronounce it. We're going to call it validate expression. And it's going to receive string expression. String expression. And for a comment, we're just going to say, let's see here, we're just going to say helper function to validate expressions against the following checks. So, for example, if, let's just say, you know, that's going to take so long. Let's just go ahead and write the thing out. I do apologize, but I'm looking at the time here, and this is already long enough. So we're just going to say if expression dot ends with and asterisk. Just make some room here. And then we're going to use OR operators here. 1, 2, 3. So if the expression ends in an operator already, minus plus, then that's going to be an invalid. So we'll just say, again, where's our invalid? Let's copy that one. All right, so that's going to be an invalid. Else if, oh, and we're also going to return false for this method itself. just to let just to help our if statements. Else if, I'll just create the brackets there, and if so, again, if the expression is blank, dot equals rather. If the expression is blank, that's going to be invalid. We'll just say empty expression. What else can we think of? Else if, let's say maybe expression dot length, if it is greater than 16, then that's going to be invalid. Expression too long. And it'll make sense why we're doing this in a moment. I'll explain it. And again, let's return false for those. Return false. Return false. Else. That's really all we're going to handle at this point. Else, we're just going to return true. And that's going to let whichever method that uses this helper function know that the expression is valid and to go ahead with that operation. So in that case, the first method, which is going to use our helper method or helper function, is going to be append operator. And it's going to say if validate expression, current expression. So if current expression passes all of those checks, then we can say current expression plus equals operator, just like that. And otherwise, or sorry, not otherwise, and then we can then pass our update to display fragment. Now, we're not going to do an else. It's not going to do anything if this is invalid, if this returns false, because we've already handled that down here. Let's look at append decimal. It's basically the same as append operator, at least the way that I'll handle it. Now, this is the method in particular which is going to allow us to kind of break the program if we really want to. I'm only going to do very rudimentary. I'm just going to do the same checks on it as append operator, and that is not really the best way to handle it, but for brevity's sake, that's how we're going to handle it. Feel free to flesh these out yourself or anything like that. Oops, what did I do here? So, sorry, I'm confusing myself. All right. So if someone hits append decimal, obviously all we want to do is just append the decimal to the string, and we can append just by typing plus equals. I don't think I mentioned that before, so if you've been confused about this plus equals, it just appends this string to the end of that string. Okay, so, and then again, we're just going to return true. And since we're being super lazy, for this comment, we're just going to see type comment for append operator. Perfect. All right, we've got one method left, and that is our perform evaluation method. Now, this one's fairly complicated. So, perform evaluation. So what we'll do is, let's just type out a good comment here. So, if expression passes checks, pass expression, or sorry, if current expression, I should be explicit about that. If current expression passes checks, pass current expression to symbols object. So pass it to our third-party library to do its magic. And return the result. All right. So let's make sure we do some intelligent examples here, just so we don't screw this up. So that is, we can basically infer that anything here, we're basically going to look at all of these different things here and see, okay, well, all these scenarios aren't valid. So just as a quick reminder, that's going to be invalid. Something like that is valid. We're actually going to make this check down here, so I should probably put these examples down there. That would be a better way of doing this. All right. Anyways, moving on. Let's just jump into coding this thing. So, if validate expression, current expression. So if we pass all of these checks here, then we're going to use a try block because the Arity library requires it. Double result equals symbols dot eval. So this right here is the way that you actually evaluate a string with the Arity library. Symbols dot eval. And of course we pass in current expression. And why is it complaining? Double result. Oh, because I didn't handle the... So what we can do is I'm just going to click on the anywhere on this red code snippet, hit Alt-Enter, add catch clause. And so in the event that something fails, all we're going to do is just, again, just do our that's not cool message, just invalid input. And then what we'll do is we're going to type current expression equals double dot toString result. So current expression just equals the result of whatever symbols returns to us, and we're just going to kind of trust that that's sort of formatted properly, which it will be most of the time. And then one last time, we're going to say true, and we're going to return current expression. All right. Chances are I've missed something, so when I actually go to compile this, then it won't work, and I'll do a quick add-on to this. But assuming I actually managed to not fuck this up, then that's basically all we need to do for calculator, and that's kind of where we'll end this particular video. So what I'm going to do is I'm just going to see if this thing is working properly, and then we'll do the outro. Alright, so everything appears to be in working order, but we'll know when we actually get to test this application out. So that has been my lesson on writing relatively good type comments and sort of seeing how things like type comments and method stubs and examples can help us sort of figure these methods out. Unfortunately, like, I would love for a situation where I could actually do this kind of stuff live and work these things out as I go. But unfortunately, just due to time constraints, I had to kind of just go through that really quickly. So, yeah. But basically what we're going to do is I've got one more video planned for now. And in that video, we're going to just hook everything up and just make the final little changes. Like we need to update calculator presenter a little bit. We might need to make some changes to the display fragment. Blah, blah, blah. We'll get everything hooked up, get our activity set up, and we'll test this thing out. And then we'll just kind of do a wrap-up of everything that we've learned over the span of these videos. So, yeah, without further ado, good night and good luck.